Today you will be solving systems of quadratic equations and inequalities. So a solution of a linear or quadratic system. A system of one quadratic equation and one linear equation can have two solutions, one solution, or no solution. So notice in the first picture on to the left, we have two solutions because the graph and the parabola and the line intersect each other at two places. The picture in the middle is one solution because there is only one location in which the line intersects the parabola. And the third picture is no solution because the line and the parabola do not intersect. My other point. Now, so when we are solving by graphing, what we'll do is we will graph each of the equations and then identify where the intersection points are. So let's graph the first equation, the parabola. Notice that the parabola is a quadratic written in standard form. So the first thing we'll do is h equals negative b divided by 2 times a. So our negative b, negative 5, divided by 2 times negative 1, which is 5 over 2. Remember, we have to find the k coordinate, and we plug the h coordinate into the equation 1. So negative 5 divided by 2, quantity squared, plus 5 times 5 divided by 2, plus 6, okay? And it does end up giving us 49 over 4. So you can, or 12.25. You can type it into a calculator in one step. If you're using a graphing calculator, the math enter feature is very nice because it will put it into an improper fraction for you. Our vertex form then is y equals, I forgot my negative sign, negative parentheses x minus 5 divided by 2 quantity squared plus 49 over 4. Okay, now if it were me, I would make a table of values for the entire problem. I know my vertex is at 2.5 and 12.25. So I would probably start off by graphing that point first. So 2.5, 12.25, somewhere about in here. And remember, this is where our line of symmetry is, so I'm going to draw my line of symmetry. And I would probably pick points to the left and to the right. Now, in our standard form, notice that I would probably pick 0 to see where it's going to cross the y-axis. And when we replace the x's with 0, we do get y to be 6. So I'm also going to graph 0, 6. Now, notice we are 2.5 units away from the line of symmetry, so if I count 2.5 units the other way, 2, we could go ahead and graph the parabola. The other thing I could do is I could try plugging 1 into the equation, the original equation, in standard form. If we plug in 1 for x, we have 1 squared, which is 1, times negative 1, which is negative 1, plus 5, which is 4, and then 4 plus 6 is 10. So we have 110, if you want a reasonable shape. So 110, and then I reflect that, and now we can sketch it. I don't know why my parabolas always come out wavy. Now, we can graph the other equation, y equals x plus 6. That is a line because the exponent of x is 1. And it has a y-intercept of 0, 6 with a slope of 1. Oh, I graphed all my points in the wrong place. Whoops. I graphed 0, 7 instead of 0, 6. Whoopsies. Let's fix it. And there, now our two intersection points are our solutions. So it looks like we have a solution at 410. And we have a solution at 0, 6. And that's it. You just did it. K into... Now we're going to practice solving these systems using algebra. So if we look at this system, notice we have y equals a negative x squared minus x plus 6 and y equals x plus 3. Now, if it were me, because I have y equals and what y equals, I would use substitution. So x plus 3 equals negative x squared minus x plus 6. And remember, we learned earlier in this unit, to solve a quadratic, I need to have it equal to 0. I'm going to add x squared to both sides because I don't like dealing with a negative x squared. I'm going to add x, and I'm going to subtract 6. And I want to make sure everything is all lined up. So x squared plus 2x minus 3 equals 0. And now I'm going to ask myself, can I factor this guy? Well, we can. This factors 2. Factors of 3 that add to give me 2 are positive 3 and negative 1. And remember the zero product property we learned. You set each of the factored pieces equal to 0. And when we do so, we do get x equals negative 3 and x equals 1. Now we need to find the existing y coordinates. So what I would probably do is I would use this y equals x plus 3. So down here, y equals our x for that one, negative 3, plus 3, which is 0. So I have the solution negative 3, 0. And we have y equals 1 plus 3, which is 4. So we have the solution 1, comma 4. Okay, this is a 1, comma 4. So if we look at the next equation, I would probably start off doing something really similar. I'm going to take what the other y equals and replace the y. So x squared plus 7x plus 12 equals negative x squared minus x plus 12. And just like before, I have quadratic, so I want to make sure that it equals 0. So I'm going to add x squared. I'm going to add x and subtract 12. Okay, so we have 2x squared x. Ugh. Okay, so notice our greatest common factor here is 2x. So when we factor that, we have 2x times x plus 4 equals 0. And we set each of those little pieces equal to 0 from what we learned earlier in the unit. So x is going to equal 0, and x is going to equal negative 4. Now, you get to choose which one you would like to use back substitution into. It doesn't matter. You should get the same y value. I know when x is 0, y is going to be 12, because no matter which equation I use, I know I'm just going to have 12 at the end. So I'm going to have 0, 12 as one solution. The other solution, I'd probably pick the top one. So y equals take a minute or two and try the 2 example U-tries. Hopefully for part A, you do get the solution points, -5, 0, and 1, 6. For this next type of problem, we're going to practice graphing a system of quadratic inequalities. If we look at the inequality for number 1, the first thing we'll have to do is we'll have to write that guy in vertex form. Remember, to find the h-coordinate of the vertex, you'll take -b and divide by 2a. So -9 divided by 2 times -1, which ends up giving us 9 over -2, or -4.5. Now to find k, the value. So when you plug -9 over 2 in for x, you do get a crazy fraction that is the k value does end up being 18.25. So we know our vertex is -4.5 and 18.25. Okay, so if it were me, I would probably pick values left and right of that vertex. Let's try, I don't know, -3. If we plug -3 into the x in the original problem, notice we have -3 squared, which is 9, times -1, -9 plus 27, which would be -18, and -18 ends up being +16. Ugh, gross. Being 16, because you have -9 plus 27, and then -2. And 18 minus 2 is 16. Okay, if we pick something else, I don't know, let's try -2. Well, -2 would give us 12. Okay. The other thing we can try graphing is 0, which would give us -2. So let's go over to our graph. Let's see, we have 0, -2. We have -1, +6. We have -2, 12. And we have -3, 16. And then we have our vertex, 4.5 and 18.25. Somewhere up in here. Okay, so we can kind of see where our graph is going. Now remember, because this is a less than sign, our graph is dashed. And I like to do a test point still. So if I'm going to do a test point, I would pick the original problem. I would probably choose 0, 0, because I know my graph doesn't go through it. So 0 is less than -0 squared minus 9 times 0 minus 2. Is 0 less than -2? The answer to that is no. So we're going to draw our arrows pointing away from 0, 0. Okay, so if 0, 0 is here, then my arrows point inside the parabola. Okay, so now we're going to graph the other parabola, y equals x squared minus 2. And this one is much easier to graph because we have a opens up parabola shifted down 2 from the parent function. So we'll graph our points. And this graph is also dashed because it's a greater than sign. Now, if we were to do a test point for this guy, I would probably use 0, 0 again in the original inequality. And we have 0 is greater than 0 minus 2. Is 0 larger than negative 2? The answer to that is yes. So we shade the region that includes 0, 0. In other words, my arrows go towards the inside of the parabola. Now, our final step is to shade the feasible region. So in this case, it is between these two parabolas here. And that's it. Take a second and try the example you try. So hopefully you get a picture that looks something like this.